In a particular game, each of 4 players rolls a standard 6-sided die. The winner is the player who rolls the highest number. If there is a tie for the highest roll, those involved in the tie will roll again, and this process will continue until one player wins. Hugo is one of the players in this game. What is the probability that Hugo's first roll was 5, given that he won the game? What we're trying to find is the probability that Hugo, his first roll was a 5, given that he won the game. This is a conditional probability. We can break this down into 2 instances. So A is Hugo rolls a 5 on his first roll. And scenario B is Hugo won the game. So the conditional probability we're trying to find is this, probability of A given B, which is equal to the probability of A intersect B over the probability of B. And so the probability of B, Hugo won the game. There are 4 players in the game. Supposedly they all have an equal chance of winning. So the probability of B is 1/4. We just need to find the probability of A intersect B. The way to do that is by going through all the cases. So what is the probability of Hugo winning and rolling a 5 on his first roll, given that there are 0 ties? And that probability is going to be, the probability of Hugo rolling a 5 on his first roll is 1/6 times the 3 others rolling either a 1, 2, 3, or 4. And the probability of that is, for each of them, is 4/6. And since they'd all be doing that, it's 4/6 to the 3rd. So next, looking at the scenario of if there's one tie. So in this case, again, 1/6 probability of Hugo rolling a 5. And then we have to choose that person that rolls a 5 with Hugo. So 3 times 3, choose 1, times 1/6 for that person that rolls the 5. And then times 4/6 for the other 2 people that roll either a 1, 2, 3, or 4. And then once they tie, so it's Hugo and one other person that have to roll again, Hugo has a 1/2 chance, once it's a roll-off between those 2, of beating that other person. So that's the probability there. Next, we can look at if there are 2 ties. Again, Hugo 1/6 probability of rolling a 5, and then 3 choose 2 for people that would also roll a 5. And then here, it's going to be 2 people would roll a 5, so 1/6 probability for that, and square it. And then one person would roll 1, 2, 3, or 4, so times 4/6. And then now that there are 3 people in the roll-off, Hugo would have a 1/3 chance of winning there. So next, lastly, if there are 3 ties. So in this case, Hugo has a 1/6 probability, and then all 3 people are going to roll a 5, so the probability of that is going to be 1/6 to the 3rd. And then Hugo has a 1/4 probability of winning against those 3 people in the second round, or in further rounds. So this is it. The probability that we're trying to find is just, it's all of these added up. And so all of these have a 1/6 to the 4th we can factor out and then simply add them up. So 4 to the 3rd, I'll break these down into factors of 2, and we'll see why in a second, but 4 to the 3rd is the same as 2 to the 6th plus, and then going up here, that 3 to the 1 is 3 times, and then 4 squared over 2 is going to be 16 over 2, so 8, which is 2 to the 3rd. And then here, we'll have 3 choose 2 is going to be just 3, but then we multiply that by a third, so that'll cancel. And we're left with just 4, so 4 is 2 squared. And then here, the only thing we have is this 1/4, which is just 2 to the negative 2. And so from here, 6 to the 4th is, we can simplify that into, that's the same as just 2 to the 4th times 3 to the 4th. So from here, then the probability of A given B is going to be equal to 2 to the 6th plus over 2 to the 4th times 3 to the 4th. This is just the probability of A intersect B. And then we need to divide by 1/4 because we said probability of A given B, we're dividing by the probability of B. And dividing by 1/4 is the same as multiplying by 4. So we multiply by 2 squared here. And so then that's just going to equal 2 to the 8th plus 2 to the 5th plus 2 to the 4th plus 1. And I had all these in 2s just in case we'd be able to kind of easily factor here. But in this case, I just found it easier to go ahead and multiply by the 2 squared and then do that canceling. So this is what we have, still over 2 to the 4th times 3 to the 4th. And then we can just evaluate this numerator. So we have 256 plus 96 plus 16 plus 1 over 2 to the 4th times 3 to the 4th. And that's going to give us 369 over 2 to the 4th times 3 to the 4th. And 369 is 3 times 123. And then further simplifying that, 3 times 41 is 123, so we have 3 times 3 times 41. And then can cancel there, we have a 3 squared down here. So then this is equal to 41 over 2 to the 4th times 3 squared. And 2 to the 4th times 3 squared is 16 times 9, which is 144. So we get 41 over 144, which is the conditional probability we were trying to find. So 41 over 144, the answer is choice C.